Finally, let's have a look at the workflow using DOPs and Vellum, and let's build, well, a pig fountain. Let's drop down another geo, dive in there. Again, drop down our trusty old pig head and set it to easy. Gonna drop down a Vellum configure soft body here, wire in the pig head, and I'll attach two nulls here. Call one out Vellum geo, and the other one out Vellum constraints. Next, I'll drop down a DOPnet, and again, dive in there, and in here, I'll add a Vellum solver, which works just like the normal solvers in here, and I'll attach a Vellum object. And by default, the Vellum object is configured so that it takes in the initial geometry from the DOPnet's first input and the initial constraints from the DOPnet's second input. So if I wire up my DOPnet like this, first input is the geo, second input are the constraints, then highlight it and hit play, well, the simulation runs. I just don't see anything because there's no gravity in the simulation. So let's add some by diving into the DOPnet and adding a gravity force below the Vellum solver, then hitting play again, and I can see now my geometry is falling. Let's add to this a ground plane or a static object by adding a static solver here, merging this with the Vellum solver, and also creating a ground plane here like this, which I'll move down a bit. Like so. Let's clean up this network a bit and hit play again. And who'd have thought? I have my Vellum sim running again. Now, so far, so good. But where's the advantage in setting up a Vellum sim in DOPs? Well, for example, if you want to create a fountain that spits out pighead after pighead after pighead, instead of just using this Vellum object to define the initial geometry, let's drop down a Vellum source, like this, and wire this into the third input of our Vellum solver. And then I'll just copy those expressions here pointing to the DOPnet's first input for the geometry and to the DOPnet's second input for the constraints. And then let's just hit play as is. And you can see the simulation is getting really slow. Because what we did here is, once we set up our object to create this geometry and constraints, and then we set our source to create the geometry and the constraints again. So we have a constantly intersecting geometry that's on top of each other. So to get rid of that, let's, in the Vellum object, just delete the initial geometry here and hit play again. And I'm back to my normal behavior. Now the Vellum geometry and the Vellum constraints get properly created by this Vellum source. However, this is just only one head, so let's create multiple by setting the emission type in the Vellum source to continuous. And, well, I could hit play now. However, I would create a geometry every frame so they'd intersect, they'd get slow, and the whole simulation wouldn't look as convincing. So instead, let's activate this every, say, 10th frame by dropping an expression up here. So $FF for float frame. Mod 10 equals to 1. So every time where the rest of my frames divided by 10 equals to 1, we emit a new pig head. Let's try that. And we can see now that is still intersecting, so let's instead try giving this pig head a bit of a velocity. So let's have it moving in the z direction. And the way we can do that is with a simple point wrangle after we set up the Vellum geometry. So let's drop down a point wrangle, and in here all we want to do is create a vector called v for velocity. And let's set this to point along the positive or negative, let me look this up, along the positive z-axis. So 0 along x, 0 along y, and say 3 along z. And now if I hit play, Vellum takes this initial speed into account directly. So let's increase the speed a bit to say 15. And now I'm shooting out soft pig heads into my scenery, into my scene. However, they are all hitting the ground plane at the same position, thus resulting in lots of intersections and piling up there. So let's randomize this direction a bit by using a function called sample_hemisphere. Go to the help page of that, and we can see we can call this with 3 arguments, a center and bias around which this vector should vary around the center, and then just a random vector of 2 that specifies where on this hemisphere to sample. Okay, the center is our 0, 0, 1, so along the z-axis, Then the bias, let's for now set the bias to 5. The bias can be any number between -1 and infinity, with 0 being unbiased. So let's finally add this u vector. Should be a vector 2. And let's use just the random value of our time times 111 plus, say, I don't know, 43. Okay, let's have a look at this. Well, a bit slow maybe, so let's multiply this vector by 10. And we can see now our pigheads get shot out in different directions. Now, the one thing that bugs me with this, apart from the fact that we're shooting out pigheads into our scenery, is they are a bit too soft. So let's dial those in, which we'll do in the Vellum struts constraint here. And the factor I'd like to dial in is the stiffness, which at 10 is really not that stiff. So let's increase this by a factor of 10 to 100, which makes for a bit more bouncy pigheads there, which is more what I'd like to see here. I'm just looking out for any collision errors, for any intersections that would require me to dial up substeps or constraint iterations, but it's looking good so far. So let's play this back in real time, and I see I have this very silly looking pig cannon, which is quite fun actually. So that is your basic Vellum setup using DOPNet. In the next video, which will be the 4th and the last video of this mini-series on Vellum, we're going to look at another very useful tool that comes with the Vellum toolset, which is the detangle node. Until then, just a reminder, if you'd like to get a bit more in-depth knowledge on Houdini, check out our Patreon. We've got a few in-depth courses there, as well as some additional content, such as render files. And also, we'd like to thank everyone supporting us there on Patreon. You guys really make this all possible. And a very special thank you goes out to Kyoko Sakane, Martin Ögren, Joseph Howerton, Nick, Chris Hebert, Refik Anadol, Rob Bryant Jr., and Mohamed Alabri. Thanks so much, guys.